This question is related to topic light. In this question, a student is reading about the wave nature of electron. The wave particle duality means that particle can behave like a wave can behave like a particle. And remember, this is for microscopic particles, they can behave like a wave. Like electron is there, a very small diminished particle can behave like a wave. So he write a statement about the wave particle duality. If every particle has a de Broglie's wavelength, it should be possible for a moving car to have the same de Broglie wavelength as a fast moving electron, although the car would be moving very slow. Determine whether the student's statement about the car is mathematically correct. So what student suggests that it is possible for a moving car to have a same wavelength as a moving electron. So moving car and moving electron will have the same wavelength. So we have to show mathematically it is correct or no. So how we can show mathematically it is correct? So lambda is equals to h over mv. That is the formula which relate the momentum and the wavelength and explain the wave particle duality. So if we are finding the wavelength associated with the electron and we are finding the wavelength associated with the car. So lambda, the wavelength is equals to Planck's constant, which is 6.63 into 10 to the power minus 34 divided by m, the mass of electron. The constants are there. This is a constant value. So it is given at the end of this paper. So 9.11 into 10 to the power minus 31 kilogram. You will use this. This is a constant value you can find at the end of the exam paper. Multiplied by speed at which the electron is moving. So electron is moving at a speed of 1.5 into 10 to the power 7. Where for a car, lambda, that is 6.63 into 10 to the power minus 34 divided by mass of the car. The mass of the car is given 900. So first what we will do, like we can compare the speed at which the car is moving and the speed at which the electron is moving. So first we work out the wavelength, because students said that the wavelength associated with the car will be same as wavelength associated with the electron. So mathematically we have to say whether it is correct or no. So lambda is equals to h over mb. When we work out the wavelength associated with the electron, that is 4.8. When we solve this, 4.8 into 10 to the power minus 11 meter. And if we assume, if we consider car is also having the same wavelength, so it will be 4.8 into 10 to the power minus 11. This is 6.63 exponent minus 34 divided by 900 into v. So we will solve for speed of the car. When we calculate the speed associated with a car, so it is 1.5 into 10 to the power minus 26 meter per second. So you can clearly see this is a very small value. So student determine whether the student statement about the speed of the car is mathematically correct. Like student is saying every particle, there's a de Broglie's wavelength associated. It should be possible for a moving car to have the same wavelength as a fast moving electron, although the car is moving very slow. So when you compare the speed of the electron with speed of the car is coming out a very small value. So mathematically, student statement is correct that the car is very slow, electron is very fast, but car is having more mass, electron is lighter. So when they have the same de Broglie's wavelength, the speed of the car is very slow as compared to speed of electron. So mathematically, student is correct. Then suggests why the de Broglie wavelength is not useful property for a car. because normally this is applied for a single particle. Car is not a single particle, it is like a combination of many particles. So when this de Broglie wavelength is applicable for microscopic single particle, or even if group are there, group of particles, but like not too many particles. But for a car, it is a combination of so many particles. That's why it is not useful, or the de Broglie's wavelength equation is only demonstrated or explained for microscopic particle. That's why for a car, it is not a useful thing. So here suggests why the de Broglie wavelength is not useful property for car. So it is only applicable for microscopic particles. For small particles or microscopic particles, but for car it is a like lot of particles it is made up of. That's why we don't have to use the de Broglie's wavelength.